Hello everyone, I'm going to talk about 427 construct quant tree.
Quad tree.
Quant tree, yeah. The question is given n times a matrix grid of the zeros and ones only. We want to represent grid with the quant tree. Return the root of the quant tree representing grid. A quant tree is a tree data structure in which internal node has exactly 4 children. Besides, each node has 2 attributes. True if the node represents a grid of ones, or false if the nodes represent a grid of zeros. Notice that you can assign the value to the true or false when its leaf is false, and both are accepted in the answer. True if the node is leaf node on the tree, or false if the node has 4 children. We can construct a quant tree from the 2
dimensional
arrays using the follow steps. If the current grid had the same values, or 1 or all zeros, set its leaf true, and set value to the values of the grid, and set the 4 children to the none and stop. If the current grid has different value, its leaf to false, and set value to any values, and divide the current grid into 4 subgrids as shown in the photo. Recurse for each of the children with the prop subgrid. If you want to know more about the quant tree, you can refer to the wiki here. Okay, wiki here is a quant tree. Okay, I think it is very useful when you do the graph system, like map. And that's why I think when I look in these problems, a lot of companies, Uber and Google, there's some system design problem relative to this. So what is the quantum tree format? You don't need to read this section for solving the problem. This is only if you want to understand the output format here. The output represents the serialized form of the quantum tree used the level order traversal, where none signifies a path terminator where no node exists below, is very similar to the serialization of the binary tree. The only difference is that the node is represented as the least its leaf value. If the value of its leaf or value is the true, we represent it as 1 in the list. And if the value of this leaf or value is false, we represent it as 0. Okay, so like this one. So 0, 1. So we can have its leaf is 0, its leaf 1, its leaf 1. Okay. Example 2, this is one is bigger, and all the values in the grid not the same, so we divide its grid in the 4 subgrid. This one is the same. Divide its 4. This one is the top right. Okay, so how could we solve these problems? We can so to check something here, return build grid 0, 0, and grid length. At the beginning it should be for example, this one should be 8. And this one is the row and column. Node build build the Gradle. Right, and int row, int lab, int column, int size. If you can check, you can see the node here has the okay. So at the beginning, we have to check if the is the same. Gradle row column size. Is the same. The same to check like this, right? This one is not means not same. Column size here. Int current value is equal to the row and column here. And for the I stuff from the row, plus the size, I plus plus, to check a row for here. For int j equal to the column is smaller than column plus the size, j plus plus. Check this one. Row stuff from here, right? So current starter size is should be the 8. 1 plus 8, 0 plus 8 it should be the here. And if the grade I plus j is not equal to value, we can return false, which means we need to keep separate for this one. If it is, we can return true. Size plus 1 here, right? Wait a second. For row for here, column is 0 0 and plus the size 8. You can see here current row is 8, and current row it should be the 0 0. So it should be the 0 plus 8 is equal to 8. And for here columns j should be the 0 plus 8 should be the 8 here. So which means we need to check for the Gradle 8 and 8, which means this, right? So if they are different, so we need to separate. If they are same, return true. Return true. Oh, this already has the return true now. And if I plus plus, then will be the. Right, now we can keep doing this one. Return the new node grade row column. If equal to true, equal to 1, then we can. It should be true. New nodes. we need to go to the current here is new node. We return for here is 1. Okay. Equal to it's the same. It's not same. It should be. It will go to the. It will return back equal to false. Then it will go into. But we can check for this one. This one should be the same. So which means return the new row columns, right? So it's not equal to the node. This one means it's the leaf. You can see here. This means the value, and this one is leaf. It's the leaf because they are same, and then equal to 1. Value is equal to 0, right? True, then it should be 1. If this one is 0, it's false. So actually it will equal to 0. And in this map, this question is already make sure all 1 and 0. So all the numbers is only has the 1 and 0. It will not be other numbers. Okay, so now we come back for this problems. And this one it will not be the same, and then which means we need to separate it. So how many levels we need separate? We need to check. So which means we have to half, right? Half means the size divided by 2, and then keep doing the same thing. Top left is equal to the build grid, and the row column half. Which means start from this one. Row left half size. This is the size about the. And then note the top right is equal to build the grid row plus the top right. This one. It should be the row have the same, but the columns have different. And node button left is equal to the same thing. Row plus the half, column didn't change. Half, yeah. And for the node button right, need to change the both column and the row. And then return the new node. True, right? Is leaf? It's not leaf because we go to the next level and top left, top right. Just copy here. Left, top right, top button left, top button right. I can see here the value, right? That value is means the The value use the 1, 0 to, yeah, the true if the represented by the 1 is for the okay, so this one is mean the true. Wait a second. Notice you can assign the value to true or false when the leaf is false, and both are accepted in the answer. So which means this one you can set as the false or true no matter. Doesn't care about this one. And then when the everything is finished, we actually return this one. This is the leaf, so we can check. Yep, and for the time complex thing, can we analyze? Yeah, analyze. Time complexity should be the TC is n square log. The space should be the n square. I see. So n square, how can I? Oh, this is same. So this one is the n square time because this for loop, and for the log. So based on this one, how many level? It's a log n level. That's why log n here. And then for the space, right? So the worst case is kind of like every nodes you have to start it, which means the n squared level. That's why n squared is the space complexity. Yeah, thank you.